In this video, we're going to graph tangent and cotangent functions that have horizontal and vertical translations, as well as other types of transformations mixed in. So the full scope of how complicated a transformed tangent or cotangent function can be is what we're going to be graphing in this video. Okay, so here, the first thing we want to do is put this into a form where we can clearly see the transformations that are taking place. So what we'll do is let's write this as, let's do 1/2 cotangent. And then now let's factor out a 2 to get the x with a coefficient of 1 minus 3 pi Okay, so now we can see from this, starting with cotangent x, it's going to be shifted to the right 3 pi over 2. It's going to be scaled by a factor of 2. It's scaled down by a factor of 2 about the x-axis, scaled down by a factor of 2 about the y-axis, and then everything shifted down 1. All right, so what we can do is we can still go from, we should be fine going from 5 to minus 5. It's just going to be shrunken in a bit. Okay, and now, so the period is going to go from, the period of cotangent and tangent is pi. The period is going to be scaled down by 2, so the period is going to be pi over 2. Now, cotangent, the idea is with tangent and cotangent, we want to sketch one period and then just copy and paste the period up and down the graph. The base period that we focus on with cotangent is going from the first vertical asymptote is at the origin, and then you go out one period in the positive direction to get to the second vertical asymptote. So, all right, in that case, let's do pi over 2. Okay, now we can sketch the, let's draw in like the imaginary shifted x-axis. It shifts down 1. We could put that in, try and make that really a faint color here. All right, so yeah, the original cotangent, like this is the vertical asymptote and this is the vertical asymptote. Okay, but we've scaled down to where now the vertical asymptotes would be here and here, right? We've scaled by the x-axis down by 2. Okay, that's fine, but then from there it's also been shifted 3 pi over 2 to the right. So what we're going to do is we're going to come out here, and this is going to be where the vertical asymptotes are going to be. Okay, so let's see, what else? Is there anything? No, so we have to consider the scaling about the y-axis of 1/2, but we'll do that in a second. So we know at the middle of this, it's going to go through the kind of wherever the x-axis is, so that would be here. Now this is cotangent, and it hasn't been flipped or anything, so we expect it to do something like this. But it's going to be kind of shrunken in a little bit vertically because it's been scrunched in by that 1/2. So what we want to do is, now to help us with the shape, we want to plug in, a quarter point here and a 3/4 point here, and plot the point. So let's see. Each of these tick marks is pi over 2 divided by 5 is pi over 10. So 3 pi over 2, let's see. Okay, well, actually what we can do is, though, we can see the period's going to repeat. We're still going to have a graph here. Instead of having to figure out what this point is, we're still going to have a graph here. So let's just plug in let's see. This is pi over 10. This is 2 pi over 10. This is pi over 5. So this would be what? At the quarter point would be 3 pi over 20, right? Because pi over 10 plus pi over 10 divided by 2. This pi over 10 plus pi over 20. Yeah, so let's see. 3 pi over 20. Okay, let's plug that in. So times 2 minus 3 pi, okay, cotangent of that divided by 2 minus 1 plus that. So yeah, it's going to be, so minus 0.63. So that's going to be, let's see, each of these tick marks is 1/2. So yeah, we expect it to be, let's see, we expect it to be, yeah, so this is minus 1, so this is minus 0.5, this is minus 0.75, so like right in there. Now it's symmetric, it's like an odd function with respect to the imaginary x-axis, so we would do like that. Okay, so it's been like scrunched in. Like that. And there we go. There's the graph. You can see it's like, it's hard to, it depends on the scale. You know, I could change the scale and make this look really stretched out even without changing the graph. But the idea is it kind of scrunched it in with that 1/2. But again, it's hard to, if you go graph this in a software, it might look, it just depends. Like we could just change the scale to 20 to minus 20, and then all of a sudden it looks really stretched out. So it's hard to see, but that's the idea. It scrunched it in with that scaling of 1/2, and it scrunched it in with this scaling about the x-axis of 1/2 as well, compared to the standard cotangent. Okay, let's put this into a form where we can see the transformation more clearly. All right, so we've got, let's see, 2/3 tangent. Let's factor out this 3/4 to get the x by itself. And then pi divided by 3/4 is 4 pi over 3. And then minus 2. Okay. So we should be good doing, I mean, let's do this. Let's do 3 to minus 3. Make it a little bit easier to draw because we're going to be scaling down here. Yeah, so what this tells us that we're going to be shifting to the right 4 pi over 3, scaling by the x-axis by 3/4, scaling by the y-axis by 2/3, and then shifting down 2. All right. So let's see. The period is normally pi, but we're going to be scaling by 4/3, scaling by the y-axis by 2/3, scaling by the reciprocal of this 4/3. So we're going to be taking pi and multiplying it times 4/3. So the new period is 4 pi over 3, because originally it was pi. Now, okay, with tangent, when it's unshifted, it's like equidistant. The period is divided around the origin. So it starts off, it's like if this is minus pi over 2, it goes to from minus pi over 2 to pi over 2. We've scaled this from pi to 4 pi over 3, so it would be 4 pi over 6 to the left and 4 pi over 6 to the right. What is that? 2 pi over 3 to the left, 2 pi over 3 to the right. That's what it would be if it wasn't shifted, but it is shifted by the period. So what it's going to be is, we can do this. So, all right, 1, 2, 3, 4, 5. It's actually, since it's shifting by the entire period, we're going to be sketching here, but we actually could just sketch at the standard position anyway, since it's shifting by a period, right? But we'll go ahead and sketch it here. So, okay, 1, 2, 3, 4, 5. So what we'll do is, let's see. Well, actually, I'm not going to make this. I don't like to do it if we've got some kind of unconventional quantity. I'm not going to make this like 4 pi over 3. So I want to make it like pi over 2 or pi or whatnot. So let's do this. Let's do pi, 2 pi, 3 pi, 4 pi. All right. So we're going to be going from we're going to be going from half the like we're going to be starting at half the period out from the origin. So at 4 pi over 6, which is 2 pi over 3. So where is 2? How many tick marks is 2 pi over 3? Well, there's 5 tick marks between here and pi. So each tick mark is pi divided by 5. So okay, 2 pi over 3, and divide that by pi over 5. So 3 1/3 tick marks is, okay, 1, 2, 3, right here. This is where the period is going to start, where we're going to sketch. Okay, now we're going to go 1 period from here. So 4 pi over 3, or no, this is, what is this? This is 2 pi over 3. Now we're going to go, so okay, a period is going to be this times 2. So we want to go this plus this, 10 tick marks to get to, that's here, the end of the period. Right, so 2 pi over 3 plus 4 pi over 3 should be 2 pi. 4 pi plus 2 pi is 6 pi. 6 pi over 3 is 2 pi. That's right, okay. All right, now let's see. We can draw we're going to be shifted down 2, so we could draw that, kind of sketch that into the background. So, okay, each of these tick marks is 0.3, 0.3, 0.6, 0.9, 1.2, 1.5, 1.8, 2.1. So minus 2. Well, okay, let's not do that then. I'm going to make this 5 to minus 5. Okay, so in that case, we've got 1, 2. So this is where the new x-axis is. Okay. So now where's the midpoint here? So, okay, this is a period. We want to divide this by 4. Okay, so now add that to where it starts. This plus, so 5 tick marks is the quarter point. All right, the halfway point is, so, okay, what we're going to add to that, let's see, is this times 2. Six and 2/3, so 5 tick marks, 6 tick marks, 6 and 2/3, so right in there. And then 3/4 is, let's see, this times 3, and then add to that this. 8 1/3. So 5, 6, 7, 8 1/3. There's the 3/4 point. Okay. So we know that this is going to, okay, there's no flipping. Well, that doesn't matter here. This is going to pass through the x-axis at the midpoint. Okay. Now we can plug, if we plugged in pi, what do we get? So let's see. Y of pi is, so 3 pi over 4 minus pi is minus pi over 4. So tangent minus pi over 4 is minus 1. So minus 2 minus 2/3. Minus 2 minus 2/3. So 3 over 3 times 2. So minus 6/3 minus 2/3. Minus 8/3. So minus 2 and 2/3. So, okay. Here we're at minus 1, minus 2, minus 2.5, minus 2.75. So right in there. And then it's like, this is like odd about the imaginary x-axis here. So the 3/4 point will go, let's see, about up, that same distance up. Okay. So let's see. Let's draw this like that. And there we go. There's the graph. Okay. This is already written in a form where we can see the shift is pi over 2 to the left, scaling about the x-axis by 1/2, scaling about the y-axis by 2, and there's a flip about the x-axis, and then shifting up 1. All right, so let's do, we can go 5 to minus 5. We can draw in, this could be this vertical shift up 1. Okay, now cotangent, the standard cotangent goes from 0 to 2 pi, like that first period is from 0 to 2 pi. Now, there's been a scaling of 1/2, so the period is normally pi for tangent and cotangent, but here it's going to be pi over 2. So you can imagine this shrinks down to pi over 2, but then it also gets shifted to the right pi over 2. So, okay, if we go from 0 to pi, and then now we're at, let's say, 1, 2, 3, 4, 5. That's 0 to, let's say that was pi. Or no, let's say we went, so 0 to 10 tick marks out. This is 0 to pi, and then it got scaled down to 1, 2, 3, 4 to pi over 2. And then it got shifted pi over 2. So really what's going to happen is it's going to do this. Come over here. But it's shifting 1 period. So we could just sketch it in this region anyway, and it wouldn't matter, but we're going to go ahead and sketch it here. Now, it's cotangent, which is normally like that, but it's been flipped, so we expect something like this. Okay, so, all right, we'll do, so 1, 2, 3, 4, 5, let's do this, pi over 2. Okay, so the vertical asymptotes, what we're going to sketch is going to be here, and at x is equal to 0. Okay, so now at the midpoint here, we know we're going to pass through the x-axis, and then okay, for the scaling of 2 about the y-axis, we're going to get that when we plug in points here. So, all right, let's plug in. So, okay, each of these tick marks is, well, okay, minus pi over 2 divided by 4 is, so it's pi over 8 is the quarter point. So let's plug in minus pi over 8. So minus, okay, x is equal to minus pi over 8 plus 4 pi over 8, that's pi over 2, is 3 pi over 8. 2 times 3 pi over 8 is 3 pi over 4. So cotangent 3 pi over 4 is minus 1 times 2. 1 minus this is 3. So at the quarter point, which would be what? Like 1 1/4, we're going 3. So 1, 2, 3. So this is 1, 2, 3, 4 tick marks. So at the, let's see, we go 1 1/4. So here's the 3/4 point, and then we need to go 1 down to here. Okay, let's draw it. Okay, now let's copy this. And there we go. There's the graph.